U.S. Army retired Major General Peter Gallagher, SVP Programs, Support, and Solutions over at CACI. Sir, always a pleasure sitting down with you.
Likewise, George. I enjoy our time together. Thank you.
So we're here again, INDOPAC 2025. I want to talk specifically with you, resilient, survivable, secure communications. What does that mean, big picture, for INDOPAC?
I think what it means for the commander of INDOPACOM and all of the subordinate organizations that could find themselves in a conflict here is having a network transport that allows them to fight and win in a contested environment. When they know they're going to be contested in the electromagnetic spectrum, they know they're going to be contested in space and in cyberspace. And so, it's absolutely critical for INDOPACOM that the network be modernized in order to provide that resilience and that secure backbone and that capability that the warfighters are going to need in this theater.
You've been in this space for a number of years. How have you seen long-haul communications change over that time span?
Well, the multi-path, multi-orbit, the evolution of proliferated low Earth orbit satellite constellations on the commercial side. Think SpaceX or OneWeb or a variety, Amazon Kuiper. The fact that you now have high capacity, low latency network transport that extends the range in a theater that absolutely where range is critical. The tyranny of distance in INDOPACOM is everything is beyond line of sight for the most part. So having that backhaul, that long haul capability, and going back to the resiliency, having redundant paths of network connectivity provides some resilience there. And so I think it's absolutely critical to have that advent of being able to exploit those new technologies and those capabilities to support the theater and their network transport is mission essential. And I think a big part of it is enabling and interconnecting all these various paths. It's everything from undersea fiber optic cable to terrestrial, long range line of sight systems to multiple airborne and range extension systems to technology in space. I mentioned low Earth orbit, but there's also mid-Earth orbit satellite constellations and the geosynchronous orbit, which the majority of military SATCOM in the past has been geosynchronous. The deal, having that redundant path offers, the communicators and the commanders on the battlefield multiple capabilities in order to connect. And I think that's really important. But the key to that is software-defined networking. So beyond the transport, it's interconnecting all those different means with what's called a PACE plan, primary, alternate, contingency, and emergency, which really just means you have a backup to the backup, and you have another means, when all else fails, right? And so what the military has been looking for is to automate the PACE plan. And doing that, they're leveraging things like software-defined networking, smart routing capabilities, leveraging AI algorithms to, make the network more self-healing. All of those things in a theater like INDOPACOM are absolutely critical to ensure command and control, fires, and sustainment and logistics. All those things depend on that network backbone.
For the department, is it a given at this point that no matter what the path, zero trust needs to be built in from the outset?
Yeah, absolutely. I think, I mentioned software-defined networking, but zero trust is critical to, it goes back to the cyber threat that I talked about before. If you know you're going to be contested in cyber, you've got to assume that any operator on the network is going to be the weakest link. And you don't want to trust them implicitly to make bad decisions, because typically, and it's not always malicious intent that causes a problem with the network. It's people making silly mistakes. And so a zero trust architecture helps prevent against that. And it also allows you to kind of understand who should have access to what based on, their attributes and what type of access do they need based on the position they hold. And so I think, attribute-based access is key, but also zero trust, working together to ensure that you have identity management, who's on the network, and what the role-based access is really what we're talking about. But it's also ensuring that you got the cyber risk equation set with a zero trust architecture that really enables the network to be secure from end to end, protecting the data from end to end. And it starts with, don't trust everybody, ensure you know who's going to be on the network and they have the credentials to operate on that network.
I've heard a phrase here, General, both on stage, in a couple of conversations here on the floor. Forgive the ignorance of this question, but optimized transport layer. What does that mean? Why is it important to INDOPAC?
So the transport layer is really, it's everything from tactical radio systems to cellular, like 5G, 6G, future G, the cellular network, which is, so you have like mesh radios, traditional tactical radios. That's a part on the very edge. And then you have, what we're used to with wireless and cell phones and all that. And I mentioned earlier, terrestrial fiber, high capacity microwave, line of sight systems, beyond line of sight systems like satellite, all of that provide this multi-path connectivity and redundancy that is the transport layer. That's how the bits and bytes flow across the network from one device or one user to another user or to a multitude of users. That's how it interconnects. And that transport layer has to be, going back to the start and the whole purpose of this, it's got to be resilient. Okay, it's got to be survivable in that contested environment, and it has to be secure. Going back to the zero trust architecture.
I've heard a number of times some of the Department of War leadership talk about moving to a posture that is both reactive and proactive in cyberspace. I'm going somewhere with this, but relative to the spectrum, is there an application we need to focus on about countering adversaries relative to spectrum?
Yeah, absolutely. And I think one of the keys is having access to data and understanding what that data means. And I know in Army Cyber and in CyberCom, General Stanton, who's now with DISA, he was very active back when he was in U.S. Army Cyber years ago of putting together this big data platform to sense and understand everything that's going on with the network. And I think having access to that and then leveraging tools that enable continuous monitoring so you can understand everything that's going on in the network from the endpoint all the way back to the big server farms and everything in between. And I think having, the indications and warnings of, potential cyber threats, there's a variety of companies that provide them, capabilities to do this, but it is really all about, managing the risk all the way down to every single endpoint. And it gets much more significant when you think about the number of sensors that are being proliferated on the battlefield now. Everything from wearables to, unmanned systems and everything, that all these different sensors that are out there, they all have to be interconnected, and they all they expand the cyber surface area and the risk, the potential risk factors. And so, again, if you work it back from edge device into the enterprise, and you've got the methods in place to protect those sensors and those all the distributed communications nodes that are out there, that's what kind of goes back into ensuring that secure part. You talked about resilient, you talked about survivable, but enabling the security of it, against all the potential cyber risks is critical. And it goes back to its endpoint security, it's defense in depth. But, in the past, in many cases, we were playing catch up in cyberspace. We had been very reactive. If an event would happen and you would go try to isolate the problem and take, different systems off the net, and you'd spend countless hours trying to analyze what happened, why did it happen, and you would have to wipe hard drives and I went through this when I was a J6 in Afghanistan, where we had to basically shut down the entire Afghan mission network and isolate a problem. And it was during, we had troops in contact. General Petraeus was the commander, and and the threat was perceived to be so strong by NSA and Cybercom that we had to, take this stuff off the network. And the cause of it was a spillage. A well-meaning individual in a joint intelligence center accidentally let some high-level traffic onto a lower level of classification. It created a cyber incident based on an individual mistake. Now there are tools in place to prevent that, protect against that. There's algorithms being established that help do protective measures in cyberspace. You have tools in place to make you more proactive. And it really starts with continuous monitoring and constantly monitoring the network and identifying those indications and warnings that there is a threat. And in some cases, the tool itself will mitigate against the threat. And it's less manpower intensive nowadays than it used to be, but the risks aren't slowing down. There's still, adversaries are finding creative ways to try to do nefarious things in cyberspace. And so it's a constant game of cat and mouse. But I think in terms of the overall Department of War and all the organizations out there, we're much more proactive today than we were just a few years ago.
General, before we went on the air, you mentioned one area that really excites you about this incredibly nuanced field, and that's optical communications. Talk about optical communications and why that's such an exciting field to be in right now.
Well, it's again, I mentioned the proliferated LEO and the high capacity, low latency. With the optical comms, it is amazing throughput. And inside our company, CACI, we are providing satellite crosslinks, for miles and miles in space, thousands of miles in space, interconnecting, crosslinks across satellites, which because it's optical, it's it doesn't suffer the same risk of radio frequency. And so, and it works really well in space. It works really well from space to air. Free space optical comms can work in the terrestrial environment, but it suffers, the elements can have an effect. And when I say the elements, it could be weather, it could be, clouds, it could be, if the path is broken by, something coming in between. It too is a line of sight communications means, but just the amount of throughput and the laser beam, basically it's laser beam like communications.
Yeah.
And so it's hard to detect. It's what you would call low probability of intercept, low probability of detect. And so that, from that aspect, it's good, but it's also very high capacity, very high bandwidth, which allows a lot of throughput.
Peter Gallagher, CACI, sir. I learn something every time we talk.
George, it's always a pleasure. Thank you.